What if I told you that right now, as you watch this video, an object traveling at 33.5 kilometers per second is tearing through our solar system, and it's not from here. It's not from anywhere within 4.2 light-years of Earth. And according to a leaked James Webb image that was never supposed to go public, this interstellar visitor might be carrying chemical signatures that shouldn't exist in the same place at the same time. The comet is called 3I Atlas, and what the world's most powerful space telescope may have seen is causing private discussions among astronomers that you were never meant to hear. Stay with me here, because by the end of this video, you'll understand why this single blurry image could reshape everything we thought we knew about how solar systems form across our galaxy. Here's where it gets absolutely insane. Comet 3I Atlas is only the third confirmed interstellar object humanity has ever detected entering our solar system. The first was Oumuamua in 2017. The second was Borisov in 2019. But here's the thing. Oumuamua came and went so fast that we barely got any data. Borisov was chemically similar to our own comets, so it didn't teach us much that was surprising. 3I Atlas is different. According to the leaked preliminary spectroscopic analysis from James Webb, this comet appears to contain both water ice and carbon monoxide in abundance, combined with what early readings suggest might be organic compounds in concentrations we've never observed in an interstellar object before. That's like finding a snowball from another country that contains both Arctic ice and tropical fruit perfectly preserved inside. Those things shouldn't exist together in nature, and yet here it is, screaming past us at nearly 120,000 kilometers per hour. Scientists are scrambling to verify this data, and the question keeping them up at night is devastatingly simple. What kind of solar system creates something like this? Okay, to understand why astronomers are losing sleep over this, you need to understand what comets actually are and why interstellar ones matter so much. Think of comets as cosmic time capsules. When our solar system formed 4.6 billion years ago from a massive spinning disk of gas and dust, most of that material got pulled into the sun or condensed into planets. But some of it, the leftovers, got kicked out to the far edges of our solar system, frozen in time. These became comets, dirty snowballs made of ice, dust, and frozen gases that have been preserved in the deep freeze of space for billions of years. Now, here's what makes comets from our solar system predictable. They formed from the same original cloud of material that made our sun and planets, so they share a common chemical fingerprint. Water ice? Check. Carbon dioxide? Check. Some ammonia, methane, and organic molecules? Yes, in specific ratios that we've measured again and again. We know what our comets look like because we've been studying them for decades with spacecraft like Rosetta, Stardust, and Deep Impact. This is where things get strange. An interstellar comet, like 3I Atlas, didn't form from our primordial cloud. It formed around another star, possibly billions of years ago, possibly in a completely different part of the galaxy. The chemistry locked inside that comet is a direct sample of alien solar system formation, and we've never had the technology to truly analyze one until now. James Webb Space Telescope changed everything. Its mid-infrared instrument, called MIRI, can detect molecular signatures with unprecedented precision. When 3I Atlas was first spotted, astronomers knew immediately that this was possibly the single most important observation target since Webb launched. But JWST observation time is extremely limited. Every hour is fought over by research teams around the world. Normal protocol requires months of review, scheduling, and coordination. What happened with 3I? Atlas broke that protocol. Emergency override observations were triggered. Directors approved target of opportunity programs at unusual speed. And then, silence. For weeks, the astronomy community heard nothing official about what Webb found, just rumors, just whispers in private Slack channels and observatory coffee rooms, until someone leaked a preliminary data image. And what it showed was not what anyone expected. Now, what I'm about to reveal in the next few minutes goes deep into the actual science of what this leaked image might contain. If you're fascinated by discoveries that challenge our understanding of the universe, you're exactly who this channel is for. Hit that subscribe button right now and turn on notifications, because I cover breaking space news like this every single week, and some of these stories disappear from headlines before mainstream media even notices them. The Comet community is small. The insider information is hard to get, but I bring it to you. All right, let's get into what this leaked image actually shows. The story of how this image leaked is almost as fascinating as the image itself. On July 1st, 2025, astronomers at the Atlas survey in South Africa first detected an unusual object in the sky. ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, was originally designed to spot asteroids that might threaten Earth. But telescope operator Larry Deneau noticed something unusual about this particular blip. The object's trajectory was all wrong. See, everything in our solar system orbits the Sun in roughly the same direction, with orbital paths that curve back around in ellipses. Even long-period comets from the Oort cloud follow these gravitational rules. This object wasn't curving back. It was on a hyperbolic trajectory, meaning it was moving too fast to be captured by the Sun's gravity. It was passing through. Within 48 hours, observations from multiple telescopes confirmed what Deneau suspected. This was an interstellar object, only the third ever confirmed. The astronomical community went into overdrive. Dr. Megan Schwamb at Queen's University Belfast was among the first to submit a target of opportunity proposal to the James Webb Space Telescope. Her team argued, correctly, that this was potentially a once-in-a-generation observation opportunity. Here's where the timeline gets murky. Normal JWST scheduling takes weeks to months, but according to sources who spoke on condition of anonymity, the 3I Atlas proposal was approved within days. Some researchers called it the fastest approval they'd ever seen. Webb observed the comet in late July. Then, nothing. No press release, no preprint paper, no social media announcements from the observation team. For a discovery of this magnitude, that silence was deafening. On August 14th, a low-resolution image appeared on an astronomy forum. No source attribution, no verification, just a spectral plot and a fuzzy infrared capture labeled 3I Atlas MIRI Preliminary. The post was deleted within hours, but screenshots had already spread across the internet, and what they showed sent shockwaves through the small community of comet researchers. 3 distinct spectral peaks where only 1 or 2 should logically appear. The chemical fingerprint of something that seemed to break the rules of how icy bodies form. All right, let's break down what this leaked spectral data actually shows and why it's causing such confusion. When JWST's MIRI instrument looks at a comet, it doesn't just take a picture. It captures the infrared light being emitted and absorbed by the gases surrounding the comet's nucleus. Different molecules absorb and emit light at different wavelengths, creating a unique pattern called a spectrum. Think of it like a molecular barcode. Each chemical leaves its own distinctive mark. In the leaked 3I Atlas image, three major features stand out. First, there's a strong water-ice signature around 3 microns wavelength. That's not shocking by itself. Water ice is common in comets. It's the most abundant volatile in most known cometary bodies. Second, there's an unusually prominent carbon monoxide signature around 4.67 microns. Again, CO exists in comets, but the strength of this signal, relative to water, appears higher than any comet we've studied from our own solar system. Here's where things get genuinely weird. Third, there's a broad absorption feature between 3.3 and 3.5 microns that some researchers are tentatively identifying as complex organic molecules, possibly polycyclic aromatic hydrocarbons or PAHs, possibly something else entirely. Dr. Stephanie Milam, a planetary scientist at NASA Goddard who has worked on previous JWST comet observations, was quoted in a private message leaked alongside the image. If this is real, we need to rethink volatile delivery models. The ratios don't match anything from our formation region. Let me translate that for you. In normal planet and comet formation, there's a concept called the snow line. This is the distance from a young star where it's cold enough for water ice to form. Closer in, it's too hot. Farther out, you get water ice plus other frozen volatiles like carbon monoxide and nitrogen. The ratio of water to carbon monoxide in a comet tells you roughly where in a solar system that comet formed. High water, low CO, formed closer to the star. Lower water, high CO, formed in the outer frozen reaches. The 3I Atlas ratio, according to the leaked data, doesn't fit either scenario cleanly. It suggests formation conditions that would require an extremely unusual protoplanetary disk structure around its parent star. And then you add in those organic signatures. Complex organics form through different processes. They can be created by radiation hitting simple ices over billions of years. They can form in dense molecular clouds before stars even ignite. They can potentially be products of biological processes, though that's an extreme hypothesis no serious scientist is jumping to yet. Having abundant water, abundant CO, and abundant organics in these specific ratios is like finding a geological sample that contains both volcanic rock and coral fossils. The conditions for creating each one seem mutually exclusive, and yet, there it is, a single object carrying all three signatures through interstellar space. Dr. Alan Fitzsimmons at Queen's University Belfast, who has studied interstellar objects extensively, put it this way in an interview from before the leak. Every interstellar object we find is a message in a bottle from another star system. We just need to learn how to read the message. If this leaked data is accurate, the message from 3I Atlas might be telling us that solar systems across our galaxy are far more diverse than our models predict. But wait, just when you thought you understood what this comet might be, there's a major complication. Not everyone believes the leaked image is showing what it appears to show. Dr. Dennis Bodowitz, a cometary scientist at Auburn University, posted a now-deleted response to the leak, suggesting that the unusual spectral features could be artifacts of preliminary data reduction. In simpler terms, the image might not have been properly processed yet. Here's the thing about raw JWST data. It doesn't come out of the telescope looking like a finished photograph. It requires extensive calibration to remove instrument effects, cosmic ray hits, and thermal noise. That third spectral peak that everyone is excited about, the one suggesting complex organics, it falls in a wavelength region that's particularly noisy for MIRI observations. Without proper calibration, you can get false positives that look like molecular signatures but are actually just instrumental artifacts. If the leaked image is truly preliminary, as the file name suggested, it might not have gone through full calibration, which means the most exciting part of this discovery could be a ghost, a phantom signal that will disappear once proper science is done. But here's where it gets even more complicated. Other researchers are pushing back on the skeptics. Dr. Cyrielle Opetum, an expert in comet spectroscopy at the University of Edinburgh, pointed out in a comment thread that the water and CO signatures appear too consistent to be calibration errors. Those molecules are well characterized. If those are real, she argued, there's no reason to automatically dismiss the third feature. There's also a timing issue that's raising eyebrows. Why hasn't the official observation team released any data yet? Normally, when JWST makes a major discovery, there's a coordinated announcement, press release, journal paper, the whole scientific process. 3 weeks of silence is unusual, extremely unusual. Some astronomers are speculating that the team is frantically trying to verify the organic signatures before going public. They don't want to announce something extraordinary only to retract it later. Others have a more cynical theory. They suggest that institutional pressure might be slowing down release, that someone, somewhere in the approval chain, is nervous about the implications. And then there's a third group who thinks the whole leak might be a hoax, someone with enough technical skill to fake a plausible-looking spectral image, generating buzz for attention. We've seen hoaxes like this before. The Oumuamua, alien spaceship rumors, the Mars face. Science attracts people who want to believe in extraordinary things. But here's why I personally think this leak is likely genuine. The specific technical details match what we'd expect from a real MIRI observation. The wavelength coverage, the resolution, the noise characteristics. Creating a convincing fake would require intimate knowledge of JWST instrumentation that few outside the astronomical community possess. Plus, multiple astronomers who I follow privately have indicated, without confirming anything directly, that something interesting is coming regarding 3I Atlas. The truth is probably somewhere in the middle. The comet is real. The observation happened. Some of what the leaked image shows is probably accurate, but we won't know for certain what 3I Atlas is telling us until the official analysis is complete. And that uncertainty is driving the comet science community absolutely wild right now. Okay, I genuinely want to know what you think about this. Drop a comment below telling me which theory you believe. Theory 1, the leaked image is real, and 3I Atlas carries genuinely anomalous chemistry from an exotic alien solar system. Theory 2, the organic signatures are calibration artifacts, and the final data will show a more ordinary interstellar comet. Theory 3, the entire leak is an elaborate hoax designed to generate attention. I'm going to read through every single comment because, honestly, some of you know things I don't. This community has aerospace engineers, amateur astronomers, and people who work at observatories watching this channel. Your perspective matters. Let me know what you're thinking. Beyond the immediate controversy, there's a bigger picture here that affects all of us. If the leaked 3I Atlas data turns out to be accurate, the implications cascade across multiple scientific fields. For astrobiology, finding complex organics on an interstellar object would suggest that the building blocks of life might be transported between star systems. The panspermia hypothesis, the idea that life's ingredients could spread across the galaxy on objects like this, would get a significant boost. For planetary science, those unusual volatile ratios would force us to reconsider our models of how protoplanetary disks evolve. Maybe the chemical gradients in forming solar systems are more complex than we thought. Maybe there are formation pathways we haven't discovered yet. For cosmochemistry, every new interstellar object gives us data about the average composition of stuff between the stars. If 3I, Atlas, is genuinely unusual, it might represent a rare type of formation environment. Or it might suggest that our sample size is still too small to understand typical versus atypical. And for future space exploration, there's a tantalizing question: could we ever catch one of these visitors? There are serious proposals for interstellar object intercept missions. The European Space Agency has been studying a concept called Comet interceptor that would park a spacecraft at a stable point in space, waiting for a suitable target to fly by. Imagine if we could physically sample something like 3I, Atlas, send back actual material from another star system. That mission might still be a decade or more away, but discoveries like this, controversies like this, are what drive the funding and attention that make ambitious space missions possible. Every time we find something we don't understand, it pushes humanity a little further toward the stars. Here's the hopeful part of this story. Even if the leaked image turns out to be partially or fully inaccurate, 3I Atlas isn't going anywhere for the next several months. It'll remain observable as it swings around the sun and heads back toward interstellar space. Multiple telescopes around the world are tracking it. Webb isn't the only instrument capable of spectroscopic analysis. Ground-based observatories with adaptive optics are gathering their own data. The Vera C. Rubin Observatory, coming online soon, is specifically designed to detect objects like this. We might find dozens of interstellar visitors over the coming decade. The era of having only 3 known interstellar objects is ending. A new chapter of interstellar astronomy is beginning. And when the official 3I Atlas results are finally published, whether they confirm the leak or contradict it, we'll cover it here immediately. Science is doing what science does: questioning, testing, demanding proof. The truth is coming. We just have to wait for it. But this isn't the only strange story happening in space right now. NASA's Juno spacecraft just captured something bizarre in Jupiter's atmosphere that mission controllers are calling unexplained. There's a growing controversy over private companies mining asteroids and who owns what they find. And astronomers might have finally solved the mystery of what caused the WOW signal 47 years ago. If any of those topics sound fascinating, make sure you're subscribed with notifications on, because those videos are coming soon. Thank you so much for watching all the way to the end. You're part of the reason this channel keeps growing and why I can keep covering stories like this. Remember, somewhere out there, a messenger from another star is racing past us, carrying secrets written in chemistry and frozen in ice. And, for the first time in history, we might actually be able to read the message. Keep looking up. I'll see you in the next one.